Isaac Newton was a brilliant scientist. He lived in the 1600s. Newton gave us 3 laws of motion. These laws are incredibly important. They explain how objects move. They are the foundation of classical physics. Newton's laws are simple, yet powerful. They describe the universe around us. From the smallest atom to the largest star, these laws apply. They help us understand everything from a falling apple to the orbits of planets. Before Newton, people didn't really understand motion. They had ideas, but no real explanations. Newton changed all that. His laws gave us a framework to understand the physical world. These laws aren't just for scientists, they're for everyone. Understanding them helps us make sense of our everyday experiences. Newton's first law of motion is about inertia. Inertia is an object's tendency to resist changes in motion. Simply put, an object at rest wants to stay at rest, and an object in motion wants to stay in motion. Imagine a soccer ball on the grass. It won't move unless something kicks it. That's inertia. The ball wants to stay still. Now imagine that soccer ball rolling. It will keep rolling in a straight line at the same speed. It will only stop if something like friction or another player stops it. That's inertia too. The ball wants to keep moving the way it's moving. The heavier an object is, the more inertia it has. A bowling ball is harder to move than a soccer ball, right? That's because it has more mass and therefore more inertia. Inertia is why you feel a push back in a car when it suddenly stops. You are in motion and your body wants to stay in motion. Newton's second law of motion tells us how force, mass, and acceleration are related. Force is any push or pull. Mass is the amount of matter in an object. Acceleration is a change in an object's speed or direction. This law can be summed up with a simple equation. Force equals mass times acceleration. This equation tells us a lot. It means that a heavier object with more mass will need more force to accelerate at the same rate as a lighter object. Think about pushing a shopping cart. It takes more force to push a full cart than an empty one. Why? The full cart has more mass. To get the full cart moving at the same speed as the empty one, you'll need to push harder. This law also explains why a sports car accelerates faster than a truck. The car has less mass, so the same amount of force from the engine results in greater acceleration. Section 4 Law 3, Action and Reaction. You can't touch without being touched. Newton's third law of motion is all about action and reaction. It states that for every action, there is an equal and opposite reaction. Forces always come in pairs. When you jump on a trampoline, you push down on it. This is the action force. The trampoline pushes back up on you with an equal force. This is the reaction force. It's this reaction force that sends you up into the air. Rockets work because of this law too. The rocket expels hot gas out of its engines. This is the action force. The gas then pushes back on the rocket with an equal and opposite force. This reaction force propels the rocket upwards. Even simply walking involves this law. You push backward on the ground with your foot. That's the action. The ground pushes forward on your foot with an equal force. That's the reaction. This is what allows you to move forward. Section 5. Newton's enduring legacy. Why these laws still matter. Newton's laws of motion are fundamental to our understanding of the universe. They are the cornerstone of classical mechanics. Engineers use them to design bridges and airplanes. Physicists use them to study the motion of particles and planets. Understanding these laws helps us predict how objects will move. This is incredibly important in many fields, from sports to space exploration. More than 300 years after Newton, his laws are still taught in classrooms around the world. They continue to inspire new generations of scientists and engineers. Newton's laws are a testament to the power of human curiosity and the elegance of the natural world.